Hey guys, this is my Ariens Zoom 1640 mower, which means it's a 16 horsepower engine and it's got a 40-inch deck on it. And this zero-turn mower has an issue, and that is the mower deck is in need of repair. I'm going to show how to rebuild the mower deck on this, specifically how to replace the bearings in the spindles for the 3 mower blades. Ariens does not recommend, or Ariens claims that you can't replace just the bearings and you have to replace the spindle assembly. In other words, Ariens basically is saying this whole assembly right here, this hub with the shaft and the bearings inside, is replaced as a unit. The current price for the genuine Ariens one for this model is about $124 each, and that's times 3. They have an aftermarket one you can buy for around $75 each, and then I think I've even seen a kit where you can get 3 of them in the kit at around $60 each for like a total cost of like $180. But the bearings that are inside here are actually pretty cheap, and you can get good quality replacement bearings for around $8 to $10 each, and there's 2 in each. So my aim is to get away with repairing these existing assemblies for around $20 a piece, $60 total. And then on the top of the deck, we've got some idler pulleys in that are also in need of replacement, and I'll show you the part numbers for those aftermarket parts also. The blades on this unit all rotate in this direction, counterclockwise when looking at them from the bottom, which means that the bolts tighten like conventional bolts. These are not reverse thread, so we want to turn these bolts counterclockwise to take them out. Now the trick is to keep this from spinning when you're trying to turn this. I also want to show you real quick just how bad these are before I take them apart. So the middle one is the best of the 3. A little bit of noise in there, but it spins freely. The bottom one is worse. It sounds horrible. And the top one was actually seized, and I had to grab the blade and turn it to get it to break free, and it doesn't spin freely. So that one's really bad. So I'm going to use my impact driver to take this off, which is going to make this a lot easier. If you do not have an impact driver, you're going to have to wedge a block of wood in here to keep this from turning, and then use a socket with a breaker bar. This is a 15/16 inch socket, just shy of 1 inch. That washer actually cracked. So you got a thick spacer, a bolt, and a washer. Just the act of giving that a really good spin with the impact driver freed this up. But it still sounds horrible. And when this is running, it's going to make the deck really loud. These 2 spindles here are easy to get to, but this one right here, there's a plastic shroud bolt guard on the top there that's in the way. And when you go to turn the screw on the top, the bolt on the top, or the nut on the top to undo it, this turns on the bottom. Well, I see what they do. They put the bolt through, then they have a nut that clamps the bolt in place, and then they have a second nut that holds the shroud on. So what's happened in this case is that this bolt is loose. Alright, so now from the top side of the deck, the guard that I have to remove is this plastic guard right here, which is held on by these 2 bolts that stick up. And the way they did this is they have the bolt coming from the bottom, they put a nut on to clamp it to the deck so that you can loosen this nut without the whole thing turning on you, theoretically. But one of them worked out fine, but this one here, the nut was stuck on there so badly that it was just unscrewing the whole thing. So this became loose. So I finally was able to get this nut off, get the guard off, tighten this back down, so that'll be ready when I go to put this all back together, hopefully. All of that is to expose this pulley because the spindle assembly has to drop out that way. It won't fit through this hole. Boy, that pulley is messed up. How that happened. Alright, so to get this pulley off, you got to unbolt it. And to get this bolt out, you have to keep this turning. So you've got to figure out a way to keep this returning. I don't recommend trying to grab onto the pulley. For one thing, strap wrench will probably just slip. And if you get a pipe wrench large enough to grab onto this, you still might damage the pulley. This hub on the bottom here, though, you can grab onto with a pipe wrench. The top, it rotates clockwise, so you would think that they might have put a reverse thread on this so that it tightened as it ran, but they didn't bother doing that. So this is regular old lefty loosey righty tighty. I don't recommend using a impact driver on this because this is only a 9/16 inch bolt. Blue on the threads, which explains why they didn't bother doing a reverse thread on this, because this gets Loctited in. What I'm going to do is I just cracked loose the 4 nuts that are on the other side of these carriage bolts that hold that hub in place. And what I'm going to see is I'm going to see whether or not, if I take the nuts all the way off, if I can drop that hub down so that the bottom of this pulley is resting on the 4 carriage bolt heads, and then tap this out in that direction. Alright, so I reinserted the bolt, so I have something to bang on that keep me from damaging the threads, hopefully. I'm not going to wail on this too hard. And there you go. Pulley is damaged, but it's not from me using a puller on it. Probably somebody had this out previously. That would explain why that is crushed like that. So after they got done replacing this, they just stuck that bent pulley back on into service. I'm going to do the same thing, but I'm just going to try and unbend it. So up until this point, we haven't done anything that you wouldn't do if you were a, if you were going about doing this with strictly Ariens replacement parts. And that would mean replacing this entire assembly right here that I have in my hand with a new one. However, if you are like me and you would like to avoid paying the big money they want for this assembly, there are 2 bearings inside here that if we can get to them, we can measure them, order replacements, and put it all back together and get away with it, doing this at a fraction of the cost. Now, here's where it gets tricky. The way this is put together, the shaft gets inserted from this side, and from what I understand, this part right here, the blade carrier, for lack of a better term, this actually threads onto this shaft. Alright, so listen, don't get crazy. There's a lot of guys showing how to do this, and they're showing all kinds of creative ways to get this interesting nut, for lack of a better term, off. Several ideas come to mind. You could find 2 dowel pins that fit in here and tap them into these holes, and then stick a bar in between the dowel pins at this angle here, and that would allow you to turn it. But it could slip off, you could have problems. You could also put the dowel pins in and then clamp the dowel pins in the jaws of a bench vise. Okay? and then turn this whole assembly with a big pipe wrench. I saw one guy, he took a piece of plate metal, drilled a couple of holes through it at exactly this length, put a couple of bolts through, and then he had a friend weld a big nut onto that plate, so then he could just grab it with a regular socket or a wrench or a breaker bar. That's all fine and dandy. What this was probably designed for was a tool like this. Okay, this is a spanner. This particular one is an Armstrong 34-107 1.5 inch. The spacing is good. The pins are a little undersized. If this wasn't super tight, I could probably get away with putting a helper pipe over this handle, but I run the risk of damaging the pins on this, and I might need this for a job down the road, so I don't really feel like screwing this up. And I'm not going to buy a special one of these just to do this job. So get a load of this. Good old pipe wrenches. These are aluminum rigid brand pipe wrenches, so they're made in the USA, and they're aluminum, and they're expensive new. But you could pick these up cheap enough at flea markets and yard sales and stuff like that, or you could just buy regular old cheap steel ones from like Horror Freight or wherever, right? And what it's going to cost you to buy some big wrenches like this, either used or cheap Chinese, is easily going to be offset by how much money you're going to save by doing this job. If you come this far, you're probably planning on doing this anyways. I'll put my wrench on there. So it was too tight for me to get it loosened out here on the ground with just the pipe wrenches. So what I did was I put it in my vise, and I held this part in the vise jaws, clamped it down really tight. Tried turning this with a pipe wrench. It was really, really tight. Then I hit it with a torch, just a MAP gas torch, one of those Benzomatic ones, easy to pick one up at Home Depot, cheap enough. Don't need a oxyacetylene or anything that hot even. And just gave it like 3 or 4 minutes of heat, and then put the wrench back on it, and it popped right off. So not that difficult at all to unscrew these. Once this is off, now it's just a matter of pressing this out through the bottom, and then that'll expose the first bearing right here. And chances are when I push this out that the other bearing might even come out of this housing with the shaft. I don't know. Alright guys, so this is like the perfect tool for this job. This is my Horror Freight 20-ton shop press. So this thing, with the coupon, this thing cost me like around 150 or 175 bucks. And this was a Father's Day gift to myself quite a few years ago. And you can do this job with an arbor press, which is a smaller bench top type press. So if you can get a hold of one of those, or you have one of those, great. But if you have one of these, even better. And if you don't, like I said, if you don't have either one, this can still be done. You just need to support it like this under the flange really well. Put a block of wood on top of here, and bang away to your heart's content. And that is the happy sound of it breaking free. And I don't know if you could see that on the camera, but it just popped down. All right, that spacer I got on there is not going to fit through there, but I'm down far enough now that I can probably just tap it out the remainder of the way, and just wiggle it out. You can see it's pushed out, so the bearing came out. So the bearing's still on that shaft, so I'll have to deal with that, but that's no big deal. Alright, so I'm back over here at the workbench where the lighting's a little better, and yeah, just wiggle that pops out. So bearing number 1 stayed behind. This is the bearing right here. Okay, that one feels really crunchy. Bearing number 2 is down, pressed into here. Okay, it's right here. And that bearing actually feels pretty good. It sounds and feels pretty decent, but since I've gone through the trouble of taking this apart, I am going to replace both bearings in each one of these assemblies. This is kind of like a dust cover. Keep stuff from getting down in there, although these are sealed bearings anyways. This bearing is clearly marked China. 1641 RS, which is a known good bearing number. RS stands for rubber shielded. That means that this bearing, which we can already see, has a rubber shield. This is a fully sealed bearing design. Oddly enough, they're saying the OD is 2 inches, ID is 1 inch by 0.5625 height. So I'm just going to grab my digital calipers because they're handy. Yeah, that's it. 2 inches. ID. Oh, this is a sleeve. Like, why isn't it coming out right? All right, so this is, yeah, that's going to be a 1 inch shaft. This is a spacer sleeve. This keeps the bearings when you're pressing them back into this housing. Creates a spacing between them. So I got to get that sleeve off. So what I want to do is I want to order myself 2, 4, 6 of these bearings. These 1641-2RS bearings. I can get them on Amazon for $8.03 a piece with free delivery. So now I have to remove this bearing off of the shaft, and it has to go off this way. So this sleeve has to be removed, which is also stuck on there. So I'm going to put this in my press and should be able to support this right here on both sides, push in this direction, and hopefully be able to push this shaft out through the sleeve and the bearing cover simultaneously. Now we're going to install the one of the new bearings. So the dust shield has to go on first. Then the new bearing. The new bearing, I could practically slide it on. It's a light press fit. I actually cleaned this up some, but I didn't clean it up too excessively. Practically tap this on with the sleeve. Actually, I was just able to push this bearing all the way home just with my fingers. Now I have to knock out this other bearing. Well, that was really bad. Actually, it got locked up because of the fact that I was banging on it the way I did. So that's why you never want to install a new bearing by tapping on this inner race. So now this nose here, this is the end that actually is that the blade goes on, which is this end here. So this goes in like this. So I'm going to do this in the press so that it's a nice so that I'm pressing on it nice and straight. So just to be clear, when I put this in the press, I'm going to support it here and here so that I'm supporting the outer race as it's being pushed in. I don't want to just put something underneath here and push, because then I will be putting force on that inner race and I could end up damaging the bearing just like I just did on this old one. Okay, I've got this bottom bearing in, and now critical part, you're going to make sure you put this sleeve back in. If you forget to put this sleeve back in and you put this bearing in, what can happen is when you go to tighten this nut that goes on the top here, holds this all together, you can actually end up damaging the bearings. Now I'm just going to put this dust shield on this side and put this nut back on and tighten it up, and we should be good to go. I'm probably going to put some thread lock on here. I'm looking at this red stuff right here that I can see the remnants of. I'm kind of thinking that might be some thread lock that they had on this thing, and it might have been the red thread locker, which you need heat to break free. Might explain why when I heated this up it came off pretty easily. And that's it as far as replacing the bearings in the spindle assembly go. And I just got to do it to 2 more and put this thing back together. And I got a couple of pulleys I got to replace too. So what I ended up going with for bearings are these right here. These are 1641-2RS. Remember the number on the bearing that I took out was a 1641RS. The 2RS just means that it's rubber shielded on both sides, which these were, so I don't know why they use a different, little bit different number, but these particular ones are a cheap Chinese bearing, branded Triton. So I ended up ordering these from Zorro, which I've gotten some things from Zorro that, Zorro is just one of those search engine marketing companies. I don't even know how it all works, but there are all different kinds of things available through Zorro. So I went with Zorro because I was able to buy these for $4.53 a piece for a total of $27.18. And then they only charged me $5 to ship them, which is refreshing. Usually you get kind of gooned on the shipping. And $1.70 for our state tax. $33.88 for 6 bearings. Pretty good deal. So I finished rebuilding 2 of these spindles with new bearings, and then when I got to the last one, I don't know how I didn't notice this, but when I got to the last one, I realized that this whole section of this spindle housing is broken away. So the old bearing that was on here that I removed actually was completely, the outer part of the bearing was completely exposed. It almost seems to me like maybe what happened was that bearing had seized, and when it seized, it was maybe trying to spin in the housing and broke the housing apart. I'm not sure exactly how, but this is completely broken. It's broken fairly cleanly, so that's what kind of made it not noticeable to me at first. But if we look at one of the other ones side by side, you can see that basically from this point where this shoulder meets there, the side right there, from that point up, this area right here is completely missing on this one. So I was like, oh, that's a bummer. So I bought 6 bearings and I can only use 4 of them because I'm going to need a whole new housing. And I thought, well, maybe I could find a used housing online and just put my new bearings in a good used housing. But as luck would have it, I did even better than that. Got lucky, and on eBay I found this. This is a rotary brand spindle assembly, brand new. And this particular, it's made in China, it's a cheap import, but this particular seller had a couple of these, and they had already sold one, and they were looking for, I think, $35 or best offer. And I made an offer of $30 and it was accepted, and that was with free shipping. So I got this brand new for $30, and you see it's an Ariens Gravely 51510000, which is the part number 4 according to the parts list for this spindle. So it's going to be the moment of truth here. That looks bigger. Huh. The overall diameter of this spindle assembly looks to be about 5 inches, and on my original ones it's about 4.5. So although this diameter right here is 1/2 inch larger than this one, the good news is the spacing of the bolt pattern is the same. So I don't think there's going to be a problem using this. Overall height looks the same. So I think we're good to go. So also this casting covers a lot more of this this nut that supports the blade. So this bearing is bad, and what I found with this bearing, which is unfortunate, well, for starters, you can't replace the bearing in this pulley. Okay. The way they make it, it's stamped steel. It's 2 halves that they sandwich the bearing within the 2 halves, and then they most likely it's spot welded together. So it's junk. What's disconcerting about this is that this pulley, as a genuine Ariens product, is very expensive. The original part number for this is a 073000101. and I found it on Amazon, but they want a whopping $60 with free prime shipping for this bearing, which is nuts. And I found it on eBay, and same thing on eBay, about $58.50 on eBay with free shipping. So you're still going to pay over $50 for this if you buy it. I couldn't find any prices better than that. I also found out that apparently this also goes by 0731250 number, which I'm not sure what that's used in, but for some reason the eBay seller is claiming that that's the same part number for both of these. That being said, I also was not able to find a Stens replacement for this. In other words, Stens makes plenty of aftermarket pulleys for mowers, and for whatever reason I could not find one made by Stens for this. And the reason why it would have been nice to find a Stens is because the Stens ones tend to be quite a bit cheaper. But then I stumbled upon this. This is a Stens 280-123, which is a replacement for an Ariens 088-44251. And what ended up happening was I was searching online and trying to figure out why the heck is this so expensive. And I happened to come across some Stens pulleys, and I started looking at the specs, and I realized that a lot of stuff on this pulley was similar to this, except for the height of this inner hub. So I started to realize I might be able to actually just get away with making a spacer or even using washers stacked up in place of the size difference. So let's take a look at how I did on this, because this pulley cost me off of eBay a whopping like $13 and change, shipping included. Far cry from $60. So for starters, the outer shells of the pulleys are identical. As far as the diameter is exactly the same on the two. The width is the same. It's a flat belt pulley. Flat pulley, meaning that the back side of the V-belt actually rides on this. The ID of the bore in the middle is the same on both. So the only thing that's different is if you look on the back, this is kind of recessed a little bit. And this one is just about flush with this part in the middle here. On this side, you can see this stands proud a little bit more than this. In other words, this actually sticks up above the top of this flange on the pulley, whereas this one, it does stick up but barely. But the small amount of difference between these two, I don't see why I can't just make that up with some washers. So I went out and took a look at the mower deck, and of course this side right here is the side that faces up, so it's inconsequential. The fact that this is not recessed like this one doesn't matter. What's critical is how the side that faces down, because how much this sticks out determines how far this pulley sticks up from the deck for alignment purposes. So if I put the two of them down flat on the bench and I just measure from the top of this surface here to the pulley face, I can see what the difference is. So that's about 443 thousandths, and that's 500 thousandths, so that's exactly half an inch. This one is just a tiny bit less. It's about 60 thousandths. And what I figured out is I got a washer here. It's 64.5 thousandths. So I'm going to put this washer on the deck before I slide this down onto the bolt, and it's going to be within 4 thousandths, which for a idler pulley is going to mean nothing. So that's the best tip I could probably give you in this whole video, if you hung in there this long, is that if you need to replace this pulley and you can't find a deal on one, buy this pulley. Again, this is a Stens 280-123. So this new spindle assembly that I got didn't come with the key, which is kind of annoying because it would have been nice if it came with a new key, but luckily I was able to get the old key out of the other one. And it's kind of funny because the way the other one's made, this shaft actually has a shoulder on it, so you can't even take this off if you wanted to. And for that reason, unlike this one here, well actually for the same reason, this key has to be extra short. So if you don't have the old key and you go buy a new key at the hardware store, you're going to have to cut it down to that little short length so that it can fit right in here. And this goes back on. Now that other pulley can go on top. All right, I've got the mower all reassembled except for the belt guards. I'll put those back on after I run the belt, because it'll be a lot easier to get that belt routed with the guards off. But I ended up putting anti-seize blue thread locker, because that's apparently what was on these threads for these bolts that hold the pulleys onto the spindle assemblies. And then I also, these don't need any thread locker because they're self-locking nuts on these two pulleys. This pulley was still good, so we didn't change that one. So that one, oh, I guess I did loosen that one. I'll have to tighten that back down. I almost forgot about that. Oh, I know why I loosened that, because this is a belt guide or guard. It's supposed to help the belt not be able to pop off of this. But I remember I must have loosened this to make it easier to take that belt off. I sharpened the blades and reinstalled them. So now it's just time to install it back on the mower. So I bought a brand new V-belt and I'm installing it now. Now, some of you may wonder why I didn't route the belt on the deck before I put it under there. Well, you may have thought I have done that. No, I actually put the deck on and now I actually reached under there and put the belt on. If you're a Padawan belt router, you might feel more comfortable trying to lay the belt out on the deck and then get the deck underneath there. I find that it tends to fall off of the pulleys anyways while you're trying to work it, and you tend to run into a situation where you got to go under there and make sure it's properly routed anyways. So I just reach under there and route it. A general rule of thumb to help you figure out the routing on pretty much any one of these serpentine belts on one of these big mower decks is to keep in mind that you've got basically two types of pulleys you're dealing with. You're dealing with a V-groove pulley like this that has a groove in it, so the beveled side of the belt's always going to face that pulley. And then you have the other type of pulley that's underneath there, which has a flat. They tend to be the idlers and the tensioner pulleys, and they'll have a flat wall to them because the back side of the belt actually runs on those pulleys. So if you just look at it logically, it's usually not too hard to figure out. That being said, oftentimes you can Google the model number of your mower deck and sometimes you can find a belt routing diagram. Anywho, so I've got my belt properly routed, and the only pulley it's not on right now is the rear engine pulley. Now the problem is, if I try and put it on the rear engine pulley, which is a large diameter pulley back there, I'm kind of fighting the tension of the belt tensioner. That flat pulley over here that has the, it's on an arm with a big torsion spring, and that's responsible for maintaining the proper tension of the belt no matter what height the deck is at. On this side, because on the other side you've got the lift mechanism that's kind of in the way. On this side you have the easiest access to the pulley. Pop it off of this pulley. Now I'm going to go put it on the engine pulley. Now that I have it on the engine pulley, I'm going to pull this back and I'm going to look underneath here, and I'm checking to make sure my routing is still good. Hasn't popped off of any of the pulleys. Alright, so now I have to get the belt onto this pulley, but at least I'm not dealing with working underneath the motor upside down. I'm working right on top here. Not only that, but the tensioner pulley is actually right here. So the beauty of that is that I can actually get something in here and actually move that pulley over, and while I'm moving the pulley over, I can pop it on. Looks good.